Okay, and here's question 2, and the shout out this time going to Jacques. So there you go, Jacques, shouting out to you. Okay, I'll give you a chance to pause and read that if you need to, otherwise I'll just crack on straight into it. So we have the sports drink person who's shown this graph, and we have to answer the questions based on this. So the first question says, how much difference does it make according to this graph? Well, here's our time after the drink here, and here's our time before the drink. So that's 14.6 minus 13.9, and so that's going to give us 0.7 seconds, and that's our answer there. Okay, Nikita is not confident that the claim advertised is true. Give at least 2 statistical reasons why Nikita might not trust the claim. Okay, so let's look up here. First of all, we have a sample here of 20 sprinters. That's not really enough, so sample size is a problem. So let's put that down. Sample size of 20 is too small to make any call. Okay, alright, what else do we have there? We've also not told at all the conditions for each race, so we don't know whether there may be conditions which affect each. So I guess we might have some bias according to that. So we'll say conditions for each sprint not recorded. Okay. Now the question here says give at least 2. There's no reason why not to say give more reasons here. So we also don't know, or we don't have anything to compare it with when people don't have this drink. So no comparison to data where no one had a drink or had the Bolt drink. So in other words, how do we know that people don't just run faster on their second race anyway, regardless of what they drink? That's just a reason there. There's several other reasons that we could put in there as well. For instance, we have a misleading graph because there's no 0 on the axis. We don't know which average this is testing, whether it's the mode, the median, the mean, and so there's plenty more that you could put in there if you wanted to. Okay, Nikita did some research on the internet and found some more results from testing. Data is summarised in the table below. Draw a graph to clearly and accurately compare how the 100 metre average times changed from the first set to the second set. Okay, and this is asking us to draw a graph that clearly and accurately compares these times. So first of all, I guess we want to set up our axes, so we'll do that. I guess the next thing is to put in some labels on our x-axis. We also need to label these axes as well, so we'll call this one sprint time in seconds, and on the bottom here we've got first sprint and second sprint labelled, and finally I guess we really want a heading for that as well. And so there we go, there's our graph. We're ready to put some bars on it now, so we'll get that data off our table. So our first sprint, sprinters using Bolt energy drink, after first sprint they are running at 14.6, so we want to rule a line across here at 14.6, so it's about there, and then we'll rule that in. So there we go. Now we'll put in for people not using the drink. Okay, so there's our bars for our first sprint. So now I want to do the second sprint as well. So there's our finished graph. The only thing left to do there is to make sure we make it clear which is which. So my green one is non-Herbold. And just keep in mind here that you must be using a ruler. It's not easy for me to show that I'm using a ruler here on the touch screen, but you absolutely must use a ruler in your real thing. Okay, and so there's our graph. Alright, so next question is asking us, from the starter, do you think it is true that Herbold energy drink helps sprinters to run to lower their run time for 100 meters? Give your conclusion. Well, looking at these two graphs, it would appear so. It appears that Herbold is lower. So, on one hand, we can say that. So let's say yes to start off with. Yes, since Herbold drinkers run faster on the second sprint, although it would appear that, like looking at a graph, even the non-Herbold sprinters increased as well. So we'll say although non-Herbold drinkers improved their time too. What else can we say here? Well, the samples that we've got here are a problem as well. We've got 15 and 20, so yeah, I guess the samples are not very big, so so we can also say however sample size is still an issue, as 15 and 20 are still too small. And once again, we don't know what the other or what conditions are happening here. So we really need to know what's going on in these races to know that it's not biased. Okay, so more needs to be known about samples and conditions, so we can be sure of no bias. Okay, this research has used average times for 100 meters races. The researchers wonder if they should use the median or the mean as their average. Which would you recommend? Well, look, you could argue either here, so long as you back up your reasons really well. But I think, you know, median is often a good place to start, just because it eliminates the extreme values. So median, since it eliminates the effect of extreme values. What else? So the problem, or the flip side of that, is that the mean gets affected a lot by extreme values. So, for example, we could say that, for example, one slow runner of 30 seconds plus would change the mean a lot, but would not change the median. Would not change the median much, if at all. Now look, there's other stuff that you can say here, and it'll really be determined by how much time you've got left over in your test to whether or not you write more. But you have to be aware that you need to be thinking of things that relate to the question that you've been given. Alright, I'm going to stop there, and then we'll go on with the question.